Hello, everyone. Today we're going to talk about modulator. So this is a kind of circuit. So amplitude modulation. AM stands for amplitude modulation. Before we move on, let us know what's modulation, what's amplitude modulation. Let us say if you want to move from your house to the next house, it's easy, like just a few steps. But if you want to move from one city to another, it's not possible to walk or possible by just traveling through few steps. You need a carrier or you need a transport. Exactly. This is the same way messages work or information work. So if it's of a very short distance, messages can be transferred from one place to another. But if the message needs to be transferred over very long distances, it needs a carrier signal. So a carrier signal is used for transmitting a message signal from one place to another or from the transmitter to the receiver over long distances. And the process of modulation is nothing but altering the parameters of carrier signal in accordance to the message signal so that the modulated signal reaches the output. This is the process of modulation. And what is amplitude modulation? Um, Carrier message has three parameters: amplitude, phase, and frequency. So if the amplitude with the carrier frequency is altered in accordance to the message signal, then it is called as amplitude modulation. So amplitude modulation. So again, we're gonna talk or we're gonna learn about balance modulator, which is a type of AM circuit. So let's start. AM circuits. AM circuits involve modulation and demodulation of amplitude modulated signals utilizing components like amplifiers, modulators, and demodulators. They manipulate the amplitude of a carrier wave in proportion to the transmitted signal, crucial in applications like radio and broadcasting. While historically significant, they have largely been replaced by more efficient modulation techniques like frequency modulation. Nonetheless, AM circuits remain relevant in specific applications due to its simplicity and compatibility. Balance modulators. A balance modulator in AM circuits is a crucial component used to achieve amplitude modulation. It employs a balanced mixer to combine the carrier signal and the modulating signal. The balance modulator effectively suppresses the carrier signal while preserving the modulation sidebands, resulting in an amplitude modulated output. Operations. Balance modulator multiplies the carrier signal by the modulating signal. So this is actually a multiplication process where it is like the output signal or the modulated signal is a product of carrier signal and message signal, and it can also have difference and frequent and sum. So the sum is known as upper sideman, and the difference is known as lower sideman. This is a separate topic which we'll study later. It is related to modulation, but let us not go further deep into the sidebans right now. So we will see the advantages of balance modulators. Reduced distortion. So distortion is nothing but the elongation and shortening of elongation and compression of the waves. So if this elongation and compression is very frequent or very too much, then it leads to distortions where the modulated signal will reach the receiver, but it might not be of a good quality or might have some noise. Improved carrier suppressions, high efficiency, wideband operation, suitability for different signals, versatility. Now let us look at the disadvantages. Carrier leakage. Despite efforts to suppress the carrier signal, some residual carrier may still leak through in practical balance modulator implementations. Complexity. Design and implementing balance modulators can be more complex compared to other modulation techniques. Cost. The complexity of balance modulator circuits can lead to higher manufacturing costs compared to simple modulation methods. Non-linearities. Balance modulators rely on the nonlinear behavior of active components like diodes of or transistors. Sensitivity to imbalance. Balance modulators rely on the precise balance between the active components of to effectively suppress the carrier signal. Frequency dependent. Balanced modulators may exhibit frequency-dependent behaviors, affecting their performance across different frequency ranges. Now let us look at the methodology of AM circuits, or the specifically of balanced modulators. Balanced mixer configuration. The heart of a balanced modulator is a balanced mixer circuit. This circuit consists of pairs of active components like transistor or diodes arranged in a balanced manner. Each pair of components is driven by the carrier signal and the modulating signal. So these are the two types of transistors you can see. Multiplication process, as I said earlier, that modulation is a method where it is a multiplication process involving the product of the carrier and the message signal, which will result in a sum and a difference. Cancellation of carrier. In an ideal balance modulator, the balance arrangement ensures that the carrier signal component gets cancelled out. Generation of sidebands. Generation of sidebands, the multiplication process generates sum and different frequencies, which represent the upper and the lower sidebands of the modulated signal, as we said in the earlier step of the methodology. Filtering. Following the modulation process, a low-pass filter is typically used to extract the desired modulated signal while filtering out unwanted high frequencies components. Output. The filtered output represents the final amplitude modulated signal ready for transmission or further processing. So that's it for this video. Thank you.